Good day everyone, this is Sir Albert, and in this series of videos, we're going to take a look at the concepts on how to add or subtract rational expressions. We are going to break our discussion into two cases. The first case is how you add or subtract similar rational expressions. And the second case is how you add or subtract dissimilar rational expressions. Let's take a look at the first case on how you add or subtract similar rational expressions. To do this, let's take a look at first on how you add or subtract similar ordinary fractions. Similar fractions are fractions with the same denominator. For example, the fractions 3 over 10 and 2 over 10 are considered as similar fractions because they have the same denominator of 10. So what is then going to be 3 over 10 plus 2 over 10? Recall from your lesson in grade school that 3 over 10 plus 2 over 10 is going to be 3 plus 2. We add the numerators and then we add the common denominator of 10. 3 plus 2 is 5 over 10. 5 over 10 is not the final answer, because it is a fraction that can still be simplified. In particular, both the numerator and denominator can be divided by 5. So dividing the numerator by 5, we get 1. And dividing the denominator by 5, we get 2. Therefore, 3 over 10 plus 2 over 10 is equal to 1/2. In the same way, 3 over 10 minus 2 over 10 is equal to, subtract the numerators, 3 minus 2, over, copy the common denominator of 10. 3 minus 2 is 1 over 10. This is a fraction in simplified form, so 3 over 10 minus 2 over 10 is equal to 1 over 10. In short, the way we add or subtract similar fractions is to operate with the numerators and then copy the denominator. And always make sure that your answer is a fraction in simplified form. Now, this structure is very much related to the structure on how you add or subtract similar rational expressions. That is, you add or subtract the numerators, you copy the common denominator, and then you simplify the result. Let's take a look at example 1 to demonstrate these steps. Consider 5z squared over z plus 1 plus 2z squared plus 4 all over z plus 1. So the way we're going to add this is to add the numerators, 5z squared plus 2z squared plus 4 all over, copy the common denominator of z plus 1. Now 5z squared and 2z squared are like terms, so we can combine it as 7z squared plus 4 all over z plus 1. Now this is already simplified because there is no factor that's common to both numerator and denominator which we can cancel. And up to this point, the way we added this rational expression is the same as the previous example on how we added similar ordinary fractions. The difference though when you work with rational expressions is that your final answer comes with a restriction. Okay? We take note that in this expression, z cannot be equal to -1, because if z were equal to -1, then our denominator becomes 0 and we end up with an expression that is undefined. So the final answer is then going to be 7z squared plus 4 all over z plus 1, where z is not equal to -1. Your turn now. Try exercise 7.01 in Schoology.